this video, we're going to look at an example of computing the angle between two vectors. In this particular example, we're asked to find the angle between two two-dimensional vectors, one being 1, -3, and the other being 2, 5. So first of all, before we go ahead and take this up, go ahead and try this problem out on your own. The first thing you'll need to know, and let's go ahead and write this down, is the formula, which is that the cosine of theta is equal to u dot v, where the vectors are u and v, so we'll just call our first vector u and our second vector v, divided by the magnitude of vector u, and also divided by the magnitude of vector v. So there are several things you're going to have to be able to do in order to do these calculations and figure out theta. You're going to have to be able to calculate the dot product of u and v. So if you're not familiar with how to do that, you might want to stop this video and go back and read about how to calculate dot product or watch the videos on dot product. You're also, for the denominator, going to have to calculate the length of a vector, its magnitude. So again, if this is something you're not familiar with, you have to go back and either read about how to calculate magnitude or watch a video on it, because we're just going to go over it quite briefly here because it's assumed that you know this at this point, and we're going to focus on calculating theta. Assuming though that you're able to compute the quantities on the right hand side, what you then find is cosine theta. Now, once you've got cosine theta, you have to still be able to find theta, but all you have to do for this is use the cosine inverse button on your calculator. So just make sure your calculator is in degree mode for this question. There's typically a DRG or some other button on your calculator that helps you switch the mode. Sometimes it's a button that actually says mode. Also, you're going to have to locate the cos inverse button on your calculator, which just says cosine and a little -1 superscript beside it. So you might have to use the second function key to be able to access that button, or the shift key, or a key marked INV. Okay, so again, the key for this question is calculating dot product, calculating magnitudes, and then using the cosine inverse button on your calculator. So go ahead, try this out, and we'll continue together once you're done. So just hit the pause button and then play when you're ready to continue. So hopefully you've had a chance to try this out. What we have, if we continue with this question, is first of all, we have to find the dot product of our two vectors u and v. Remember that to find the dot product, we simply multiply the first components of the two vectors together and add that to what we get when we multiply the second components of the two vectors together. In our case, we're going to get 1 times 2 plus -3 times 5. And we can clean that up, do the arithmetic, and simplify in the next step. Now, for finding the magnitude of vectors u and v, remember that magnitude is the square root of the sum of the squares of the components. So for u, we're going to have 1 squared plus -3 squared, all square rooted. For v, we're going to have the square root of 2 squared plus 5 squared. So we've done the hard part now on the right hand side. We can go ahead and simplify this just using arithmetic. So in the numerator, we've got 2 minus 15, so that's -13. And in the denominator, under the first root sign, we've got 1 plus -3 squared is 9, so we've got root 10. And under the second root sign, we've got 4 plus 25, so 29. Now, we can leave this as is. We can simplify the right-hand side further. It would be nice to avoid introducing round-off error because we don't want to be doing that. We want to keep things in exact form as long as possible. We definitely don't want to introduce round-off error. So at this point, we can use the cos inverse button on our calculator. We simply enter -13 divided by root 10 divided by root 29, and once we get that, we then hit the cos inverse button on our calculator, and if your calculator's in degree mode, you should end up with 139.76 degrees. Now, if you did not get 139.76 degrees, again, make sure your calculator says DEG at the top, so that means it's in degree mode because we're working with degrees here. Other things to make sure, remember that you've actually square rooted the numbers in the denominator. That's a common mistake. Make sure that the negative sign is there, and make sure that you've divided both by the root 10 and by the root 29. So you're doing negative 13 divided by root 10 divided by root 29. Make sure you're familiar with your particular calculator, whether you have to hit the square root sign key before hitting the number, so first square root key and then 10, or the number 10 and then the square root key. Also, make sure you're hitting cos inverse and not cosine. So again, you might have to hit the shift key or an INV key or a second function key, typically before selecting the cosine button. It should somewhere say cosine inverse on a standard scientific calculator, so it's just a matter of accessing that key. So overall then, what this means is that the angle between these two vectors is approximately 140 degrees. If we wanted to check if that makes sense, what we could do just really quickly is sketch the two vectors just to get a sense of what this looks like. So the first vector has an x component of 1, y component of -3, so it looks something like this. And the second vector has an x component of 2 and a y component of 5. So it looks something like this. So yes, it does seem plausible that the angle between these two vectors is approximately 140 degrees.